Okay, so we also have to introduce some other terminology. We have these script capital letters, X and Y, okay? So X denotes the input space, okay? All the valid ways of filling out a credit card application, all the valid ways of making pictures, okay? If you're talking about the tree case, okay? All the different ways of creating those types of inputs, and Y to denote the space of outputs, okay? Here, for most of the things that we've talked about, it's been binary, right? Is it a tree or not? Yes or no. So the space of Y is actually pretty small here, okay? So what we want to do in machine learning in the supervised case really is really simple, okay? It is just creating this function, right? This function that is mapping X's to Y's, right? That's all we're doing. Okay, so we're going to say it's going to take in an input X. Okay, this is a particular instance, it's a lowercase letter, and I want to come up with an output, right? This output Y, which is, well, is it a tree or not? Is it a good loan or not? Okay, so this is the actual value, okay? The F is what is the idealized input, okay? So let me get out of that, okay? What we want to actually try to achieve. Now, with data, we often can't come exactly to the actual target value, okay? Sometimes we'll make mistakes, like the tree recognizer will fire on a cat, okay, or a lecturer, say, and say he has a tree-like haircut or whatever. Okay, so it's a misfire, and it may misidentify some trees, like maybe bonsai trees or the super trees will not be detected as trees, right? That's okay, but it just tells us that when we do machine learning, we're getting an approximation, okay? And for this course, we're going to call that approximation H. H for hypothesis, okay? So invoking this hypothesis function on a new test input should hopefully give us a target value close to the actual thing that it is, right? Is that actually a tree? If it is, then good, we got the right answer. Or if not, maybe we got a wrong answer, okay? A lot of people don't like this notation, and that's fine too. It depends on your flavor. They like to denote approximate values with a hat. Okay, so you'll see this a lot in other mathematics notations, okay, where hat means an approximated value. So if you see this over a letter, it just basically means that's not the actual value, that's an approximated value because of some shortcuts or some data loss, etc. Okay, so that's what we mean by that. So you'll see both of these. We're going to stick with this notation throughout our lectures. Okay, now there are also different learning algorithms that can be used to make an approximation, right? So maybe you've heard of some like decision trees, naive Bayes, deep neural networks, SVMs, okay? They're all different algorithms. We're going to touch upon some of them, okay? And each one of those have different ideas of what it considers a valid function, okay? So a valid function, well, again, there could be many different ones. And so we're going to see this a lot more in concept learning next week. Okay, but the idea is that we can enumerate all the different ways that we can set an idea of what a target function looks like, okay? And just like the script notation for X and Y, we have script H, okay? So this means all of the possible ways that this particular algorithm can come up with a target function, okay? An approximated target function, okay? So we basically have a way of choosing among these. Sometimes when we were choosing among these, because it might be an infinitely large set of hypotheses, then we can use some things like parameters, okay? So we'll talk about parameter tuning a lot, but basically this idea is that because the H algorithm has some knobs and buttons to push, okay? Depending on which knobs you set which way and which buttons you push, it comes up with a slightly different hypothesis, okay? So when we want to choose among all of these H's here, we can just merely tell us, what was the settings that you used? Did you push this button? Did you set this knob to 5 or whatever? And then out comes a model, okay, based on the data that you have, okay? So we're going to say these parameters theta then chooses among all of the elements in our hypothesis space, and we're going to call that a model representation, or I think we denote it as this, right? Small h of theta. Okay, that means the hypothesis, the specific one that was returned, given the parameter settings, run on a particular instance, okay, to yield a particular output. All right, everyone good with that? Okay, if you're good with that, please help us put up a yes. Okay, so I'm just going to do it here. Okay, I'm just going to check on how you guys are doing. Okay, this is just to check in that all of you are around. So I have a couple yeses here. So Ahmad said yes, Abel said yes, Alex said yes, Andy said yes. Okay, some of you are not clear. So Suning, you're not sure about this. Please raise it up in the forum. You can actually change this if you understand. If not, yeah, come and ask us on the forum or other places, and we'll try to answer it. We'll also have at the very end of class, even though it's already getting pretty late, a session where you can ask us any questions you want. Okay. So hopefully many of you who are actually participating on lecture are happy with that, okay? So now that you've answered this question, you can go ahead and clear it. Okay, you can unclick that so we can have another question later on, okay? Thank you for participating with that, okay?